All right, hey guys. Today we're going to look at composite functions, and this is for Unit 1, Lesson 2. So I shall take away my header page, and let's get down to business. All right, so what does it mean, or what is a composite function, or the composition of two functions? The composition of two functions is where you have two functions, let's say f and g. So the composition of function f with the function g is described as, let's say, h of x equals f of g of x. So this is, when you look at this, you've got one function, g of x, inside of another function, f of x. So a composite function usually represented by f of x and g of x, where f of x is a function that takes on some kind of action on g of x. Okay, that's a lot of words. A composite function is simply where one function is inside another function. So we may have a function, we'll label it or call it h of x, and it is created or obtained by taking g of x being put into x into the f function. Okay, so let's just get down to it. All right, I'm going to scoot this up. Okay, so let's say we have a function f of x, which is defined as 2x squared minus 3. And let's say we have another function, g of x, and that equals 4x. Okay, so what I want us to do, and I really didn't write it here, what I want us to do is I want us to find h of x, which is equal to f of g of x. So what does that mean? Okay, so that means that we're going to take g of x, which is defined as 4x. Remember, when two things are equal, they are the same. So since 4x is the same as g of x, we're going to take g of x, which is 4x, and put it into f. Okay, well, let's talk about what f is defined as. F is defined as 2x squared minus 3. So now if I put 4x in 4x, then I've got, here's the f function, and the g function is put into x. Now let's clean this up and we'll see what we have. So this is h of x equals f of g of x, because remember g of x was 4x. Then this is, what, 16x squared. So I have 2 times 16x squared minus 3. And that h of x turns out to be 32x squared minus 3. Okay, when you look at this function here, it's very difficult to see that the g function has been put into the f function. So 4x has been put into x, and then this is the cleaned up version for h of x. All right, same thing for the next one. Let's take, let's say h of x is defined as g of f of x. And so h of x will equal. Now this time, let's talk about and think about what we're going to put in for into the g function for x. Well, what is f? F is defined as 2x squared minus 3. And so g is going to be 4x. So everywhere I have an x, I'll put 2x squared minus 3. So h of x is going to equal 8x squared minus 12. And h of x was obtained by taking f, which is 2x squared minus 3, and putting it into the g function. Okay? And so, again, what if I wanted to find a new function, h of x, by taking the g function and putting it into the g function? So what is that going to look like? H of x equals, okay, so g, the g function is 4x. So what is g of x? It is 4x. So we're taking 4x and putting it into the g function 4x. And so that just turns out to be 16x. So the new function, h of x, is 16x. And we obtained this by taking g, which is 4x, and putting it into the g function. Okay, so now what if we want to evaluate composite functions algebraically? All right, I'm going to scoot this up some. So I want us to take the same two functions, f of x and g of x, and I want us to find f of g of 1. So g of 1, you start by finding g. So what is g of 1? G of 1 would be 4 times 1, which equals 4. So now we want to find f of what g of 1 was. We found g of 1 to be 4. So f of 4 will equal 2 times 4 squared minus 3. 4 squared is 16. 16 times 2 is 32. And 32 minus 3 is 29. So f of g of 1 equals 29. Okay, what about g of f of 1? Well, this time find f of 1 first. And that would be 2 times 1 squared minus 3. So that turns out to be negative 1. And now I want to take my f of 1, which is negative 1, and put it into the g function. And g is still 4 times x. And so that turns out to be negative 4. So g of f of negative 1 equals negative 4. We figured out what f of 1 was, which was negative 1, and then we took the negative 1 and we put it into the g function. All right, and then finally f of negative 2. Let's find f of negative 2 first. So I have 2 times negative 2 squared minus 3. That's 2 times 4 minus 3. I believe that turns out to be 5. So this is 5. So now I want to evaluate the f function at 5. So that's 2 times 5 squared minus 3. 5 squared is 25, times 2 is 50, and 50 minus 3, f of 5 is 47. Okay, so f of negative 2 equals 47. So a composite function is basically the result of one function taking on the action of another function. I mean, a composite function could even be where you take two functions and multiply them together. But most of the time we will talk about taking one function and putting it into another function. All right, so now let's look at this from a numerical perspective. So let's say you have a table of values. You have a table of values that include x values of negative 2, 0, 3, and 5. And we have 3 different functions. and the result of these three different functions evaluated at each of these x values. So being able to read a table of values is a very useful tool and a very important tool. So first thing, if I want to find g of f of negative 2, we're going to start with f of negative 2. So what is f of negative 2? Well, f of negative 2, so here's f, here's the f function. I'm going to find the x value that's negative 2, and I'm going to go to this value of 5, and f of negative 2 is 5. So f of negative 2 is 5. Now I'm going to go to the g function and go to the x value of 5, and the g of 5 will be 9. So there's your value. So g of f of negative 2 is equal to 9. All right, now let's do f of g of negative 2. So start with g of negative 2. So g of negative 2 equals, so here's g. I'm going to go find the x value of negative 2. And this value is g of negative 2, which is 0. Now I want to evaluate or substitute 0 into the f function. So now I'm going to go back to the f function and go to x equals 0, and that gives me 6. So f of g of negative 2 equals 6. All right, now what about f of h of 5? Well, find h of 5 first. So here's my h function. I'm going to go to the x value of 5, go down to the h row, and that would be 5. So now f of 5 will go to the f function and go to the x value of 5, and that turns out to be 1. So f of h of 5 ultimately equals 1. And then finally, we'll do f of g of 0. So find the value of g of 0 first. And g of 0 will be 3. And now find h of 3. So h of 3 will be 4. Okay, so it's a matter of starting inside and then working your way outside. All right, so now let's look at this from the perspective of two graphs, two functions in the form of a graph. So here we have two functions. We have an f function, the graph of f, and we have the graph of g. And I want us to evaluate, do something very similar to what we did on the last example. I want us to find g of f of 0. And so now we want to identify f of 0 first. So we're going to go to the f function, and really I guess that should be a capital F. So f of 0, the y value is 0. So now I'm going to take 0 and substitute or figure it go to the g function and evaluate g of 0, which is 4. So f of 0, we needed the y value for f of 0, which was 0. So f of 0's value is 0. Now we want to find the y value when when the x value for g is 0, which is going to be 4. Okay, these should all be capitalized as well. Okay, sorry about that. So f of g of negative 2. This says find g, the y value for g of negative 2. So here's my g function, negative 1, negative 2. The y value is negative 3. So now I want to evaluate find f of negative 3. So what is the y value of the f function when x is negative 3? So negative 1, negative 2, negative 3. The y value is 4. Okay. All right, so now we want to find f of g of negative 1.5. So I'm going to go to the g function, and I'm going to find the point where x is negative 1.5. Okay, so it's about that point right there, and that point is negative 1. So now I want to evaluate f of, what was that? What did I say that was? F of negative 1.5 is negative 1, and the y value of f of negative 1 is 2. Okay, let me walk through that one more time. So g of negative 1.5, I'm going to go to the g function. I'm going to go to the point on the graph where x is about negative 1.5 and the y value is negative 1. So now I'm going to go to the f function, and I'm going to find the point on the graph where x is negative 1 and its y value is 2. So yes, that looks right. All right, then how about g of f of 3? So now I want to go to my f function to the point on the graph where x is 3, which is here, which is negative 5. And now I want to evaluate or find the y value when for the point on the graph of g when x is negative 5. So I'm going to the g function, 1, 2, 3, 4, negative 5. Now, look at that point right there. You might think that g of negative 5 is equal to negative 1, but it does not equal negative 1. What makes this not equal to negative 1? The fact that there is an open circle at that point means that the point on this graph at negative 5 does not exist. So g of f of 3 is undefined or not defined, however you want to describe it. It is not defined because there is no y value when x is negative 5 for g. To kind of put this in perspective of lesson 1, if I were to state what the domain for this function is, my domain starts at negative 5 and it ends at positive 5. But because the point at negative 5 is an open circle, I would write my interval starting with a parentheses and then ending it with a bracket, because the point at 5 when x equals 5 is included. So just to kind of tie that in with what we talked about in lesson 1. So f of 3, we did find a value for f of 3. So I went over here to f, the f function. I went to find the point on the graph where x is 3, and that value was negative 5. So f of 3 is negative 5. But then when I went to find the value of g of negative 5, I went to the g function. I went to find the point on the graph where x was negative 5. But the problem is that this point right here is actually not included in this graph. If that had been closed, then this value would be, and actually that should have been positive 1. That should be a positive 1 there. If that had been closed, then g of f of 3 would be positive 1. But because there's an open circle there, g of negative 5 does not equal 1. So therefore, g of negative 5 is undefined. And therefore, g of f of 3 is undefined as well. Okay? All right, so we've looked at composite functions and evaluated composite functions from a tables perspective, also from a graphs perspective, and from an equations perspective. Now what I want us to do is I want us to take a composite function, and I actually want us to determine to decompose a function. In other words, I want us to find the inside function and the outside function. So, all right, so we're going to take a look at A function that is defined as h of x equals the quantity x squared minus 2x minus 2, all raised to the third power. And I want us to identify the inside function and the outside function. And so here's what I want. I want to find h of x, which is equal to f of g of x. So what I want us to identify what is the equation for g of x and what is the equation for f of x. And I think that pen's gonna lose ink. So which one is outside and which one is inside? Well, f is inside, so f of x will be the inside function, and g of x, I just said that backwards. F of x is not the inside function. F of x is the outside function. And g of x is the inside function. G of x is inside of f. So I had to write that, I had to fix that. Okay, well, let's look at this. I think when you look at this expression, what function is inside of another? Well, this expression right here is your g function. G of x is x squared minus 2x minus 2, and it is inside the f function, which looks like something cubed. Well, if you're taking x squared minus 2x minus 2 and you're putting it into a variable and then cubing it, that variable would be x. So f is your outside function and g is your inside function. All right, so let's do the same thing for this one. Let's say h of x is defined as f of g of x. So we want to identify the inside function and the outside function. Okay, so f of x equals the outside, and g of x will be the inside. Okay, so what's the inside function? The inside function is x squared minus 1, and the outside function is the square root of x. Because f of g of x, if you take g, which is this, and you put it into f, which is this, you get what you started with. Okay? All right, and then same thing here. Let's find h of x such that f of g of x. Let's say that our g of x is going to be the inside and f of x will be the outside. So f of x, what is the outside piece? What is the inside piece? Well, g of x is the inside, so g of x is this stuff, x minus 1 over 2x plus 3. And the outside, this is being put into a variable we'll call x, which is being squared. So g of x is your inside function, x minus 1 over 2x plus 3. Your outside function is your x squared. All right, and then finally, let's look at this last example. We have h of x equals x plus 1 squared minus 3 times x plus 1 plus 4. And again, we'll stick with h of x equals the function that is created or defined as f of g of x. So g, again, will be our inside function, and f will be our outside function. So f of x and g of x. So what do you suppose is the g of x? What looks like it's being put into another function? And that would be your x plus 1. So x plus 1 is being plugged into another function. But what function is it being plugged into or put into? Well, the first term of that function, f, the outside function, will be something squared, and that something is x. So you have your x squared, then you have minus 3 times that expression, so that would be minus 3x. Notice that the constant term 4 does not have an x plus 1. Well, that just means that your f function is x squared minus 3x plus 4. And please remember, you have a way to check this. All you have to do is go backwards. Identify or evaluate f of g of x. Take your g function, x plus 1, put it into your f function, and see if you end up with what you started with. So you have a way to check yourself, okay? So that's kind of the gist of composite functions. And in pre-calculus and calculus especially, we work with composite functions a lot. There's a couple of things I wanted to point out. So a composite function is in this form really right here, where one function is being put into another function. There's an inside and an outside function. You might see this notation right here look like this. And I know that that's weird. It looks like it's the word fog. But sometimes you'll see an expression where that O is a little bit smaller, and it looks like this, f of g of x, and that's all that means. I want you to recognize that this is subtraction. If you have f minus g of x, that is the same thing as f of x, the function f of x, minus the function g of x. If you have f plus g of x, that means is the same thing as the function f of x plus the function g of x. And then the closed dot here means multiplication. Take the f of x function and multiply it by the g of x function. And these are some things that you got to be aware of and be familiar with. Even with ACT stuff, you'll see these notations and you'll have to know what they mean. All right, so that wraps up our lesson 2 for Unit 1.